So we did all of this. I told you metals had a giant metallic lattice and they wanted to lose electrons, which is why they were all positive ions in a sea of free moving electrons. The electrons lost were just roaming around. So high melting points, usually group 1 metals, although don't have very high melting points, and mercury, plenty of exceptions. Good electrical conductors, malleable and ductile, and we talked about alloys being strong. Why were they strong? Because they've got a mix. They have a mixture of metals, and they've got different sized atoms, which makes it an irregular lattice, and the ions can no longer slip and slide that easily. So we talked about group 1 metals, and I told you that they were extremely reactive, and the reactivity increases down the group. The bigger the atom, the easier it is for it to lose electrons. And they would react very explosively and vigorously with cold water, and they're called alkali metals because when they react with water, they form really strong alkalis. Like Na reacts and turns into NaOH. They've got low density, which is why they float on water. They've got low melting points, and they're very soft as well. So that's group 1 metals. And we talked about group 2 metals, which were known as alkaline earth metals, very abundant in the Earth's crust, like calcium carbonate and hydroxide. And the formula of calcium hydroxide is Ca, which twice actually. And then we talked about transition metals. Transition metals were your everyday metals like silver, iron, gold, copper, tin. They've got high melting points, high densities. They're not very reactive. For example, an iron chair is not going to react very quickly with something. They're not very reactive. Gold doesn't really react with much. They've got high densities. They've got variable charges as well. For example, Fe could be 2+ and Fe could also be 3+. So they can have variable charges as well. And they're a good catalyst, lots used as catalyst in many reactions, colored compounds, and the solutions are also colored. And we did salts, different salts. We did colors of salts early on, which you had to remember. And the colors are given. And we started talking about the reactivity series. I told you that group 1 metals are the most reactive ones. Then you've got group 2 metals, group 3 metals, and then the transition metals are the ones that are kind of unreactive. So you have to remember this whole entire reactivity series. It's given in the data sheet that I gave you. So you have to remember this: KNaCa, MgAl, Zn, Fe. There's a carbon over here as well for reference, which would be used later on. And then it's SnPb, HCu, HEAg, Au, and platinum. So these are the ones that are unreactive. What does reactive mean? Reactive means metals like to lose electrons. So reactive means they lose electrons easily. And unreactive, on the other hand, means that they don't like to lose electrons. So these ones, it's pretty difficult for them to lose electrons and form ions. Gold doesn't actually like to form ions. And the first part of the reactivity series was that we started discussing the reactions with water. Okay, so we started discussing. So we started discussing the reactions with water, and we started discussing we did the first part, which was that the group 1 metals, they react explosively. You need to know the equation, and the equation is kind of the same every time. That whenever a metal reacts with water, so whenever a metal reacts with water, it's either forms a metal hydroxide or a metal oxide, and hydrogen gas is produced. So this is often asked in the paper. Sodium metal would float and fizz on the top surface, and it would melt or catch fire, and bubbles of H2 gas are going to be produced. We're going to talk about the next one, which is calcium. Now, calcium is also kind of reactive, but the reactivity kind of decreases at. Now, what's going to happen with calcium is that calcium reacts slowly with cold water. So its reaction with cold water is not that rapid. But explosively at a higher temperature. So what you'll see is that the reaction is slow. With cold water, this is what's going to happen, that that calcium, I mean, it's exactly the same reaction. Calcium would react with water and it would turn into calcium hydroxide. Plus hydrogen gas would be given off. But since it is a slow reaction, very slight effervescence is seen. So slight effervescence is seen. And calcium hydroxide that is formed is also not very soluble. TK, if you remember the solubility of the hydroxides, calcium hydroxide is not very soluble. So slight precipitate of calcium hydroxide would also be seen. So moving down the reactivity sees the reaction with water slows down. The next one is Mg, kind of has the same reaction, except that with Mg, the reaction is a lot slower. So with Mg, what happens is that the reaction is really, really slow and almost doesn't take place. So Mg has, I mean, you can say that it almost has no reaction with cold water. So again, the reactivity is decreasing. It reacts with steam at very high temperature. So reacts with steam at high temperatures. And at high temperatures, oxides are usually formed because the hydroxide will decompose. So instead of the hydroxide, you get the oxide, and kind of the same reaction, except that instead of the hydroxide, you get an oxide. So that is Mg reacting with steam only. So starting with the top, explosive reaction with cold water, calcium, the reaction slows down with cold water. Mg absolutely has no reaction with cold water, mostly reacts with steam at high temperatures. ठीक है, ये सारा clear है? What science is clear? Zainab, Saneem?
जी सर।
अच्छा, फिर एल्यूमिनियम के ऊपर ना बहुत सारे क्वेश्चंस आते हैं, ठीक है? They ask a lot about aluminium. तो एल्यूमिनियम का है कि even though aluminium is kind of reactive, but it's right at the top, but aluminium absolutely has no reaction with water at all. ठीक है? Aluminium की windows होती हैं, doors होती हैं. So aluminium has no reaction with water. Even hot water, ठीक है? Even steam के form में, it's not going to react. बेशक आप जितना मर्जी टेम्परेचर बढ़ा दो. And the reason for that is कि aluminium जो है ना, it actually does react जिसका iron react करता है और rust करता है. But the thing with aluminium is कि when you add it to water, immediately उसकी जो top surface है ना, वो react कर जाती है, turns into aluminium oxide. but that aluminum oxide layer kind of covers it. It protects it. जब एक दफा वो layer बन जाती है, तो that layer kind of covers it, surrounds it from all sides. So aluminum oxide layer uh, provides a very tough non-porous coating. Non-porous means nothing can get in now. Achha, which protects AL. So this thing is going to be asked about you a lot. That aluminum, why does aluminum doesn't react with water in any conditions? And the reason being it's got this coating of Al2O3, which is very tough. Iron जो rust होता है ना, that's not very tough. वो rust जो है ना, that breaks off very easily. But in the case, and it's not even non-porous. Non-porous means के अगर iron rust कर रहा होता है ना, तो उसके ऊपर एक red layer बन जाती है, ठीक है, which is like a powder, and it keeps breaking off. But in the case of aluminium, you get a very shiny, bright aluminium. It's a very shiny substance. So you got this very shiny, nice aluminum oxide coating, which is tough and non-porous, and which protects AL. Is this clear? This thing? I'm not clear. अच्छा,
जी सर.
अब ये कि और नीचे आते रहोगे ना, the reactions would simply slow down. ठीक है, they'll be slower and slower. ठीक है, so over here, what's going to happen is reactions with water might take years. They will happen, but over a very long time. और जितना नीचे आते रहोगे, yes, do you have a question?
Sir, when are we going to start polymers?
हम इसके बाद करेंगे ऑर्गेनिक, इसके बाद मेटल्स के बाद हम ऑर्गेनिक करेंगे, ठीक है. और प्लस I'll send you video lectures on this, ठीक है. Say this one, reactions with water take years, and they become slower and slower as you go down the group. Slower or non-existent. जैसे ये बॉटम वाले ना, ये तो इनका तो रिएक्शन होगा ही नहीं. अच्छा, but the thing is, there's one जिसकी water के साथ जो reaction है ना, we're going to study in detail, and that is iron, because iron is everywhere. We use iron a lot, ठीक है, we use iron a lot, तो उसका हम डिटेल में पढ़ेंगे कि that's known as rusting of iron. अच्छा, now that's not a very fast reaction. It takes years, ठीक है, it takes years. For example, एक chair है, it's going to take it 10-20 years. Cars are made from steel, which contains iron. So it takes 10-20 years, 30 years for it to rust. Even पानी में फेंक दो ना, it's going to take at least 4, but it's not going to completely rust. Titanic जो है वो भी it's in water. The conditions are very feasible, but it's still there. I mean, most of it is still intact. Not all of it has rusted. So rusting of iron is a gradual, slow process. The reason it's important is that we use iron a lot. Okay. So what happens is you need conditions requirement. Okay. You need warm conditions. ताकि rusting तेज हो. You need air for it. Plus you need moisture or water for it. So if you're living in a coastal city, rusting would be faster. Okay. So you need moisture or water for it. Now what happens is, I mean, if he reacts with water and also oxygen in the air and turns into Fe C+, Fe C+ is the red brown rust, So hydroxides and oxides of Fe3 plus. Okay, so this is what your rust is, the red brown rust that is formed. अच्छा, लेकिन इसके लिए आपको दो चीजों की जरूरत है. One of them is water and the other one is oxygen. You need air as well for it to happen at a faster pace. खाली अगर water होगा तब भी काम चल जाएगा, खाली oxygen होगा तब भी काम चल जाएगा, but together the reaction is a lot faster. ठीक है, so most of the time you need both things: humidity, moisture, and you need air. So that is rust. Why is it bad? Because this rust is very powdery. It quickly breaks off. तो वो जो आपका metal होगा ना, that will start corroding. ठीक है, it will start falling off. Because rust is very weak. ठीक है, it's the brown powder that you have. वो आहिस्ता आहिस्ता गिरता रहेगा. ठीक है, so your metal would slowly corrode. So this is rusting of iron. ठीक है, first thing is remember कि आपको ना ये दो चीजें चाहिए. वो अक्सर क्वेश्चन आएगा पास पेपर्स का, he'll give you a bunch of nails. किसी के अंदर वाटर होगा, किसी के अंदर एयर होगी. जिसमें दोनों होंगे वहां पे रस्टिंग ज्यादा होगी. ठीक है, ड्राई एनवायरनमेंट या लेस ड्राई एनवायरनमेंट में रस्टिंग जो है ना, दैट वुड बी स्लो. अच्छा, now we're more interested in the other thing, which is how do you prevent rusting? ठीक है, so let's say you have a car or you have a bicycle that's made out of steel which contains iron. So how do you prevent rusting? Can you even tell me one? What would you
By
do?
greasing.
So ठीक है, number one, so you can oil machines वगैरह को, इसलिए you're always giving them oil and grease. ठीक है, what that does is कि अगर आपके पास, if you have iron, तो what it does, अच्छा, if you have iron, what it does is कि it provides a coating on top so that water and air cannot get in touch. ठीक है, इसलिए आप बाइसिकल चेंज हो गया, you're always greasing it. ठीक है, so एक coating आ जाती है टॉप पे, which is non-porous. Non-porous means that the water and the oxygen cannot, they can't get close to it. अच्छा, इसी तरह और क्या ऑप्शंस है?
By putting a layer of paint on it.
ठीक है, so another one is paint, which is kind of the same thing. ठीक है, same concept कि you paint it ताकि ऊपर एक लेयर बन जाए, and the paint has to be non-porous. ठीक है, इस तरह का पेंट होना चाहिए, कार पेंट है कि nothing could get close to the actual metal. ठीक है, it would provide a surface which would block anything that from reaching the iron. Number 3 और क्या होगा?
Zinc or tin coating.
ठीक है, अच्छा, उससे पहले ना एक और इसी तरह का, that's called electroplating. फिर हम जिंक पे आ जाते हैं. ठीक है, अच्छा, इलेक्ट्रोप्लेटिंग में होता है कि सेम पेंट
By
वाला.
the help of electrolysis.
ठीक है, by the help of electrolysis. The electroplating, what you do is you coat it with some unreactive metal. But reactive नहीं, very unreactive metal. With unreactive metal like gold या silver, जैसे हम watches वगैरह को आप gold plate कर देते हो, coated with unreactive metal. And the example is gold plating. तो सेम कॉन्सेप्ट होगा कि वो गोल्ड की जो लेयर होगी ना, दैट वुड, गोल्ड इज वेरी अनरिएक्टिव, तो द टॉप लेयर ऑफ गोल्ड वुड काइंड ऑफ प्रोटेक्ट इट. ठीक है, अब आ जाते हैं उसके ऊपर. द नेक्स्ट वन इज कि you've got जिंक वाला. So what happens with zinc? Number 4. That's known as galvanizing. So what you do is you coat it with zinc or Mg. ठीक है, there's another name given to this. This is known as sacrificial protection. and you don't even actually have to coat it, okay, or provide electrical contact. I mean, connect them with a wire. अच्छा, first thing, ये पेंट वगैरह में मसला क्या है? कोई मुझे दो मसले बता दे. What's wrong with oil, grease, paint, electroplating? What's the problem with this? Why is it not a very good method of preventing rusting?
Because it is good for some period of time, but after some period of time it gets
ठीक है.
rusted.
हाँ, मतलब scratches पड़ जाते हैं. It can, I mean, the oil and grease would eventually dry off and the layer would get removed. Paint का भी यही होता है, ठीक है. अगर you electroplated with gold, so the gold could be chipped off of it. So the layers will get scratched off over a period of time. और वो जब स्क्रैच ऑफ हो जाएगी, रस्टिंग फिर स्टार्ट हो जाएगी, ठीक है. अक्सर देखा होगा कि जहाँ पे भी if you have a bicycle और जहाँ पे भी there's paint missing, it would eventually start again. So it's not a permanent solution. So the layer of will get scratched off. And another big problem is that it's kind of impractical for big objects. So small object को तो आप paint कर दो, ठीक है. What if you have a big object like a big tower, ठीक है? For example, you've got a mobile tower, ठीक है? There's a mobile tower. That's a huge tower, ठीक है? You can't ensure that it's painted all the time properly. मतलब even the first time ना, जिस दिन आप paint कर रहे हो ना, उस दिन भी ensure करना बहुत मुश्किल होगा कि वो completely painted हो. या Eiffel Tower है, ठीक है? That's so big. I mean, you can't even ensure on the first day that it's completely painted, ठीक है? ठीक है, Minail. So impractical for so it's kind of impractical for very large objects. So ship can't really paint all of it, ensure all of it is painted at even on the first day, okay? So that's why small objects के लिए ठीक है, लेकिन not for big objects. So big objects, you usually whenever you talk about big objects, you talk about sacrificial protection. As a two protection, the sacrificial and cathodic, they kind of have, I mean, the concept is kind of exactly the same. 1 second. This is kind of your fourth or your fifth pointer. अच्छा, पहले तो fourth point. Fourth point का फायदा है कि let's say you have a piece of iron. Man, let's say that's a ship made from steel. First thing is you just have to provide electrical contact. I mean, you can coat it, that's a good thing. TK, it's a very good thing. But the only thing that you need is you just need an electrical contact. TK, and that electrical contact could be through a wire. Like you can have a piece of zinc attached to it, or maybe the zinc piece is somewhere in the room and you've just attached a wire and connected it with the iron. Okay, so it doesn't even have to be exactly on the iron. Okay, it could be on somewhere, किसी room में रखा हुआ है, and you're just providing an electrical contact with it. Now the thing is, zinc is more reactive. So Zn is more reactive. And I told you, okay, what does that mean? It means that it loses electrons easily. I said loses electrons easily compared to iron. It likes to lose electrons. So zinc will try to lose electrons and will try to form Zn2 plus, and electrons would be lost. So what would zinc do? Zinc would be producing these electrons. It has a higher tendency to lose electrons, and electrons would flow, and these electrons are going to travel towards the iron. So all the electrons on iron would be coming from zinc. So zinc is slightly more reactive compared to iron. तो अगर यहाँ पे ना कोई ऑक्सीजन आ रहा है इलेक्ट्रॉन गेन करने, or a water molecule is coming to form the oxide or the hydroxide ion, वो जो negative ion है, ठीक है, वो अगर iron के पास आया है, it comes close to the iron and wants to gain those electrons. So the electrons are not actually coming from iron, they're actually coming from zinc. So the electrons, तो आप दूसरा point होगा कि electrons travel towards the iron. So the electrons gained by oxygen and water are actually coming from the oxidation of zinc. Is this point clear?
Yes.
And this is why so iron doesn't do anything, ठीक है, iron की बारी नहीं आती electron lose करने की, so iron बच जाता है, ठीक है, iron doesn't turn into an iron. So all the electrons are coming actually from zinc, क्योंकि अगर iron electron lose करता ना तो वो क्या बन जाता है, Fe2 plus, और oxygen electron gain करता तो वो बन जाता, या iron lose करता तो it becomes Fe3 plus, oxygen becomes 2 minus, and they would get together to form rust. But this time iron बच गया, iron is not turning into an iron. Okay, iron is remaining as it is. So, so electrons gained by oxygen or water are actually coming from zinc, and zinc gets oxidized in preference to iron. In preference to iron. So is this clear? This one? Was that clear, Saneem, Amna?
Yes, sir.
Yes, sir.
So yeah, this is called sacrificial protection. कि आप थोड़ा सा ज़्यादा more reactive, it's more reactive, तो थोड़ा सा ज़्यादा more reactive metal आप उसके साथ attach कर दो, and when you do that, तो जो भी इलेक्ट्रॉन यहाँ पे गेन कर रहा है वो actually इलेक्ट्रॉन जिंक से आ रहा है, ठीक है, it's not coming from iron, so iron is protected. तो आपके जो large structures होते हैं ना, they are protected in this way. आपका जो मोबाइल टावर है ना, जो बहुत बड़ा है, you can't go on कि वो उसका पेंट खराब ना हो, मतलब you can't really, मतलब गाड़ी का पेंट खराब हो जाता है लेकिन उसका पेंट सही रखना बहुत मुश्किल काम है, तो एक बहुत बड़े मोबाइल टावर को हर वक्त पेंट करना that's kind of impossible, ठीक है, तो उसके लिए you use something like this, ठीक है, नीचे they attach pieces of zinc to it. अच्छा, और एक और है इसमें कि most of the time they don't even attach a piece of zinc to it. That's known as cathodic protection. Achha, so most of the time, what they actually do is कि आपने बस एक constant source of electrons provide करने आयरन को, ताकि iron is not able to lose electrons. So what you can do is you can connect it to a electricity point. But zinc का ही काम था ना, electrons भेज रहा था. So you could just make it the cathode, ठीक है. What you can do is कि battery या वो connection लगा दो उसके साथ. You've got this piece of iron. उसको ना connect कर दो एक हल्के से current के साथ. मतलब बैटरी के दो टर्मिनल्स होते हैं, one of them is negative and the other one is positive. तो उसको ना बैटरी के नेगेटिव टर्मिनल के साथ कनेक्ट कर दो, तो बैटरी का जो नेगेटिव टर्मिनल होगा और लेट्स से जो दूसरा टर्मिनल है उसको अर्थ में कनेक्ट कर दो, तो there's going to be a slow और कोई इतना ज्यादा करंट भी ना रखो, जस्ट अ वेरी स्लाइट है, किसी को करंट भी ना लगे, जस्ट अ वेरी स्लाइट करंट, तो वो एक कांस्टेंट फ्लो ऑफ इलेक्ट्रॉन्स होगा. तो iron will be getting all these electrons, and all these electrons would actually be coming from the cathode. ठीक है, they would all be coming from cathode. So there's going to be a constant flow of electrons, and when there's a constant flow of electrons, तो जो भी यहाँ पे electrons gain कर रहा है, whether it's oxygen and water trying to gain those electrons from iron, then those electrons are not actually coming from iron. They're actually coming from the source, the current source that you've connected to it. तो ये दोनों almost एक है, almost एक. Either put a piece of zinc, तो वो constantly एक source of electrons, एक flow होगा. Anyone who tries to gain electrons from iron would actually be indirectly gaining electrons from zinc or magnesium. And the other one is cathodic protection, which is the same concept except that now you've connected it to an electrical point. दोनों के pros and cons है. उसमें मसला ये है कि वो zinc कभी ना कभी खत्म हो जाएगा. ठीक है, you have to, I mean, that block of zinc or piece of zinc has to be replaced sometime in the future. Current का ये कि वो, I mean, you have to ensure that the current is always there. Because the moment the current stops, rusting will start. Because oxygen and water will want to gain electrons. So if the battery is not providing them electrons, then iron would have to provide them with electrons, and iron would start rusting. Okay? So just remember, ये पांच तरीके. One is oil and grease. The other one is paint, electroplating. These are just you just put a coating on top. It's not reliable. As soon as the coating or the layer is scratched off, rusting start. And it's impractical for large objects. Galvanizing and doing cathodic protection, that's kind of the, and cathodic protection is usually the way that's done. बड़ी बड़ी oil rigs होती हैं, उसमें यही करते हैं कि वो rig को ना, वो जो metal rig होती है, they just connect it to the negative terminal of the battery. ठीक है, so all clear, सब clear है ये?
Yes, sir. Yes, sir.
ठीक है, बस ये water के सारे reactions, reactivity C is rusting of iron. Just remember कि the first two kind of react very explosively with water. They just explode in water most of the time. ठीक है, but you must know the observations. These are very important. Calcium का reaction cold water के साथ it slows down. थोड़े से bubbles बनते हैं, slight effervescence is seen. और फिर वो calcium hydroxide जो होता है वो इतना strongly alkaline भी होता है. It's not very soluble as well. So what would happen over there is that a slight precipitate, white precipitate would be seen. Aluminium का याद रखना, it's a favorite question, doesn't rust at all. उसको कुछ भी कर लो पानी के साथ react नहीं करता क्योंकि it's got this coating which is very tough. और नीचे आते हुए reactions slow down. It takes years for them. Any question, Naira? Any question?
Sir, is francium in our syllabus?
कौन सा?
Is francium in our syllabus?
नहीं, francium नहीं है. ठीक है. Actually, मैं वो बता दूं कि reactivity series is this, but what you need to learn is कि group 1 metals are top पे होंगे. So if they ask you about francium, although it's not in your syllabus, you don't have to remember that. But अगर if a question comes on francium, you should know कि francium is a group 1 metal. तो उसकी reactivity क्या होगी बाकी सारों के मुकाबले में top पे होगा. और फिर एक और चीज है कि reactivity increases down the group. So K or Na से ना it would be more reactive, so it would be right at the top. Is that point clear?
Yes, sir.
ठीक है, so just remember कि अगर कोई और metal आ जाता है ना, if they talk about strontium is group 2, so you must know कि उसकी reactivity इन दोनों से मिलती जुलती होगी. और strontium bottom पे है तो वो इन दोनों से ज्यादा reactive होगा, so strontium would be somewhere over here at this point. अगर कोई transition metal है, let's say titanium है, अब I mean तो idea होगा कि it must be somewhere over here. ठीक है, उसका ट्रांजिशन मेटल के अंदर ऑब्वियसली आप पोजीशन कोई उसकी क्लियर नहीं होगी, लेकिन आपको थोड़ा बहुत आइडिया होगा कि एटलीस्ट ग्रुप 1 और 2 और 3 से तो कम रिएक्टिव होगा. ठीक है, सो इट मस्ट बी समवेयर ओवर हियर. चलिए ठीक है, लेट्स कंटिन्यू विद रिएक्टिविटी सीरीज टुमारो देन. ठीक है, ओके एवरीवन,
Allah Hafiz, sir.
अल्लाह हाफिज.